everyone, a big hello to all of you. I'm Supriya Srivatsa. I'm a software engineer at Atlassian, and I'm super glad to be virtually here and be able to share my thoughts with all of you today. And my thoughts today are monolith to monolith. What does that mean? So today we're going to talk about a large monolith my team owns, why we decided to break it, and why, contrary to the popular industry trend of decomposing a monolith into a bunch of microservices, we went against the tide and decided to decompose our monolith into another monolith. So that's a lot to unpack, and before we dive deep into all of this, let's wet our feet with some terminologies first. What's a microservice? A microservice or microservice-oriented architecture is one in which your software or application is composed of several different services, right? These services would typically talk to each other over a lightweight protocol, most often HTTP. So although to the end user interface, you just see one facade, there is a constellation of services behind that is doing all the work for you for the functionality that was requested. A monolith, on the other hand, is when a software or application is composed of just one entity, right? It is pretty self-contained. And as a consequence of it being self-contained, over a period of time, monoliths tend to get pretty monolithic, isn't it? If you look up monolith in a dictionary, it's defined as very large and hard to change. Are you sensing some discontent there already? But we sure experienced a lot of discontent with our large monolith, and I want to share with you why we felt the need and decided to break down our monolith. Amongst a myriad of factors, we were able to bring them under two large umbrellas: developer productivity and service reliability. To talk a little bit more about both of these factors, my team at Atlassian, the marketplace team, we own a monolith which is more than a decade old now. And we'd gotten to a point where nobody wanted to touch it. Nobody wanted anything to do with it. And that's not a good place to be in. The developers lacked confidence in making a change in the service reliably. Meaning, touching any part of the system always left the engineers guessing if something would break somewhere else. And the use of obscure, decade-old libraries and frameworks that are not around anymore did not make things any easier. To also talk about service reliability, we have had incidents where critical functionality has been down, and we have struggled to find out what's going wrong where because we were so lost in the web of the monolith. It is super hard and super painful to try to make a fix when you don't know where to look. Having broken functionalities served to the end user is not a state we wanted to be in. So putting the hat on reliability, focusing on reliability, we decided to chip away from the large monolith pieces of code that we deemed most critical to reliability. Things that our system could not live without, the base functionality that our system strived to provide. And we began extracting these functionalities out into a separate code base. And in our case, this separate code base turned out to be another monolith. Why did that happen? So you just broke down one monolith and built another monolith? That's a very valid question. And we'll talk a lot more about all of this. So we built what we like to call the modular monolith. Considering that a lot of our pain in the past has been due to a lack of structure in the code base, we decided to double down and give great care to our code structure. And thus was born a modular monolith. So let's look at this infographic in some detail. So on the left, you have a monolith where you have a bunch of functionalities, say functionality 1 to 100. And the key thing to know and remember about a monolith is everything is accessible everywhere. Which means if functionality 2 needed to access some logic that has been implemented as part of functionality 1, but it needs it as well for some stuff that it needs to do. Functionality 2 can very well access this code for what it needs. Essentially, everything is accessible everywhere across the code base. Now contrast this with a microservice. We have a better separation of concerns. So functionalities that are tightly coupled together are put together in one microservice, and functionalities that are a little more loosely coupled are put into another microservice. And any interaction between these microservices happens over the network. Right? Now this coupling is very key to get right when you're breaking your functionalities out of the monolith, where everything was easier to cross access, out into a microservice where all communication happens over a network, right? So we'll talk a little bit more about the network effects here. But key is that when you're breaking down stuff into a microservice, you need to be very careful about how tightly or loosely coupled they are and how the interaction between them works. Now contrast this with a modular monolith. So in a modular monolith, you again see a similar separation of concerns, but instead of functionalities being bunched together in a separate service, you will see functionalities bunched together in different domains, right? Where in microservices, all interaction happened over the network, in a modular monolith, all interaction between domains happens over interfaces only, right? Contrast this with monolith, where you could access what you wanted a lot more easily. In a modular monolith, you can only access what the interface allows you to access, right? So that's a high-level view of a traditional monolith, a microservice architecture, and a modular monolith where we have functionalities in different domains. And we decided to go down the route of modular monolith instead of a microservice-oriented architecture while decomposing some features from our monolith. Why? So let's look at the why behind this decision of ours. Abstraction. So going back to software engineering first principles, we need separation of concerns, we need abstraction, we need all of that. But it does not have to be over a network. Any point in a system where you introduce a network can become suddenly unseemingly complex. And if you can avoid it, you should avoid it. Again, we need abstraction, but it does not need to be over a network. So if you're thinking of inter-service communication in a microservice architecture, think about whether the over-the-network abstraction is what you need or whether that can be simplified. Boundaries. This seems like a simple thing, but boundaries are really hard to define, and boundaries are not set in stone. Microservices that are built with poorly formed boundaries or boundaries that are prone to change just turn into really chatty microservices. So if you're not sure of your boundaries or they are likely to shift and change, instead of bounding them in microservices, consider bounding them in domains. That way, you remove an element of friction and give them the space for the system to evolve and grow as things change. So consider your boundaries very carefully. Boundaries are hard to define. Consider how they might change in the future because requirements, systems are prone to change. Look at a long horizon and see how you think your boundaries should fit into your system, whether it should be in your microservice architecture or should be bounded as domains in a modular monolith. Conway's law. So we're going to talk a little bit more about Conway's law because this played a huge role in our decision of migrating and decomposing some things from our monolith. So let's look at this. So Conway's law defines that any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. Now, what does this mean? In other words, Conway's law suggests that your code structure is very likely to mimic your organization structure. Is that right? Should that happen? Should that not happen? Let's look at what Martin Fowler had to say on Conway's law. Conway's law is important enough to affect every system I've come across and powerful enough that you're doomed to defeat if you try to fight it. Right? Now, before I talk a little bit more about how Conway's law influenced our decision in going the route of modular monolith, let's revisit this infographic that we saw earlier. So the monolith, microservice, and modular monolith. And here we see, let's focus into one functionality here, say functionality 3. We're looking at decomposing functionality 3 out of our monolith. And here is a crucial point of discussion where we look at whether this functionality, which seems to be its own domain or its own area of expertise, whether this functionality should sit in a separate microservice or whether it should sit in a separate domain in the modular monolith. Now, we had longer debates, longer discussions, longer thoughts when it came to functionality 3 of everything else, because there was something special about this and a little more nuance here. So before we look at why we made the decisions we made, let's look at the factors behind this. So what was different about functionality 3? So this time it was a little bit more than just decomposing it from the monolith. For functionality 3 to work as expected in today's world, it would also mean that we need to migrate an external dependency from system A to system B. Now this was a large critical effort, spanning several quarters, say 1.5 to 2 years, and a critical enough effort that it boiled up all the way to company level OKRs. So a large and critical effort like this naturally translated into us having a dedicated team that could, over the period of time, develop expertise in this domain and be able to shield other teams from any other work and take care of the dedicated work that this large critical effort was all about. Now, when we say a dedicated team, a natural line of thought again was that functionality 3 is its own area, it's its own domain, and we have a team owning everything related to functionality 3. It would probably be most efficient for this team to have a microservice that encompasses functionality 3 and any other related functionalities and drive it and own it, because a team needs ownership, right? Now here is where a lot of thoughts and discussions came into picture, and we were very cognizant of Conway's law. Now, business priorities change, business requirements change, team structure and team organization changes. But what outlives everything else is your code base and your service, right? We need to be really cognizant of how we design and architect our systems. In our case, instead of putting functionality 3 in a separate microservice, we decided to put it in its own domain in the modular monolith. Now, teams need ownership, but this ownership does not have to be a service in itself, right? There are two levels at which you can think of Conway's law. So when you think of Conway's law with large organizations, like large organizations within your company, it makes sense for each organization to own its own code base, own its own services. But when it comes to smaller teams that are more likely to undergo shuffling or undergo restructures without messing up the overall org balance, when it comes to such smaller teams, Conway's law needs to be looked at from a different lens and a little more carefully. So teams need ownership, but this ownership does not have to be a service in itself and can very well be a domain or a module. Now in our case, we were able to foresee and see that all of these requirements, all of this critical large effort that had come in is probably here to stay for, let's say, 2 years. Even after that, there will be work in this very domain, but you might not need a dedicated team for it. That work could be divided amongst other teams. So once that clicked in, and once we dwelled on that further and were able to see that down the line this team may or may not exist, but this code will, right? So it's very important to carefully consider the lifespan of your code base and the lifespan of your teams as you best know it, with all the knowledge of it that you have today, while deciding your system architecture itself. Now, I can confidently say today that this was a good decision, and this decision went very well in our favor, because now when we're mostly done with the migration from system A to system B, we are in the process of disbanding the original team into a couple of other teams. And if we had had a dedicated microservice that this team was owning, that microservice today would perhaps have been, lingering around looking for an ownership. You don't want a service looking for an ownership. So in hindsight, I think we got this decision right, and it has worked out very well for us. So coming back to this infographic, summing up everything we've looked at so far from the perspective of abstraction, boundaries, and Conway's law. So looking at it as abstraction, we decided that we need abstraction, but we did not need any of the other technical reasons that come along with a microservice, and thus decided to provide abstraction over domains instead of abstraction over the network. We were able to identify that our boundaries as we see them today, if we built microservices with our existing boundaries, they might tend to get a little chatty down the line. We knew what boundaries currently exist because we were able to see the usage patterns from our existing monolith, and we were able to leverage that knowledge to define our boundaries, our current boundaries. So we decided that we did not want to create concrete boundaries by having multiple microservices, but wanted to create soft concrete boundaries as domains in a modular monolith. And of course, Conway's law, which we talked about in great depth right now. Consider how Conway's law applies for your team and org sizes. And for us, we decided that considering the lifespan of the code base versus the team, having a domain which a team could own instead of a service in itself made a lot more sense for us. And thus was born our modular monolith. So in our modular monolith, we want these domains to be the abstraction in our code base, right? The abstraction that needs to be there, but not necessarily over a network. But we are modules in our modular monolith. Now, business domains drive these domains or modules, right? Be very careful about using business taxonomy to drive these modules itself, so engineers know where and what their code is driving. And interactions between these modules happens over well-defined interfaces only, exposing no internal logic. So this helps prevent the monolith from becoming a messy ball of mud, right? You're only able to access what another module permits you to access. Yeah. Shape code structure. Monoliths that you hate are monoliths that lack structure, right? Define boundaries as you best know today. If boundaries are blurred, don't make a microservice. Things are prone to change. Now, in our case, we talked about having functionality 3 into its own domain in the modular monolith, right? Down the line, if we see the need for functionality 3 to scale independently, if we see different usage patterns arising for functionalities that arise out of domain B that functionality 3 was a part of, if we see different traffic patterns, different usage patterns, and see the need for independent scaling, we will definitely consider splitting it out into a separate microservice, right? It's just not on the cards today because we don't need it today. But shaping our code such that it sits in an independent module ensures that there is enough decoupling with other domains, which means extracting out a module into another microservice is a lot easier and attainable than extracting out a functionality from a monolith in itself, right? Extracting out domain B into a microservice in future if needed is not going to be as much effort as it was to extract functionality 3 out of the monolith into the modular monolith because of the way the modules are structured and because of how we ensure that the coupling or any communication happens only via interfaces. Since we already see a strong separation of concerns, letting this system evolve in future is a lot more possible. It's a lot more extensible with modules. A key challenge here though is the discipline. So it takes great discipline to maintain this modularity. Without constant discipline and constant focus on modularity by the team, the modular monolith can quickly just become another monolith, right? Or worse of all, a ball of mud. While this discipline required to maintain the modularity, this abstraction, is hard, introducing microservices as a fix for this is not a viable solution, because writing good microservices and ensuring a healthy microservice architecture also requires discipline. And if not done well, you would just end up with a distributed ball of mud, which is several times worse, right? So the idea here is not to say that all large monoliths need to be broken down. Absolutely not. In fact, legacy is not bad. In fact, legacy systems don't get enough credit. They need to be applauded because they keep things running. They keep the business running. In fact, we still do have our original large monolith around and probably always will, because it's not feasible or nor advisable that you break away code that was written over a decade into decompose that in many ways over a short period of time. So we will probably always have our existing monolith around, except that we're chipping away the features that we require the most for reliability and second for developer productivity. But some part of functionality is always going to be there, and that's true. Neither is the idea to say don't do microservices. That's not the idea. If you have varying scaling requirements for your functionalities, etc., by all means, you should have microservices to cater to those. We do have a few microservices in our team as well, because we recognize different scaling needs and different usage patterns for these. But key is that we have a couple of microservices less in our team because we decided to invest in the modular monolith. And a couple of microservices less to own and take care of is a big deal. That's a lot of operational overhead reduced by just not having 2-3 extra microservices. Now, the idea is not to convince you of a modular monolith either, honestly. And like the answer to all complex questions begins with, it depends, one right answer to all complex questions is also do what works for you, right? Find your rhythm. Find your rhythm, but be very cognizant of abstraction, of how concrete or soft your boundaries are, of your scalability and your usage patterns, and of how Conway's law applies to your team and org sizes. So we apply all of these lenses to find what works best for you. Lastly, we choose to build our system with the best understanding of it that we have today, without guessing the future, but ensuring our system is ready to evolve and scale to whatever the future holds. And that's why we went from a monolith to a modular monolith. Thank you so much. I'm super bummed I couldn't be there in person. So if there are any questions or anything you'd like to chat about, share your thoughts, do hit me up on Twitter, and I would love to have a chat with you. Thank you so much. Thank you.